Welcome to the MAS Chemverse channel, your guide through essential courses like pharmaceutical chemistry and medicinal chemistry.
Hi, I hope all of you are doing well. It's a little long time because last week I was not healthy. I didn't posted any video in the YouTube. Really, I'm sorry for that. Now we are going to discuss about the proton pump inhibitors in today's topic. If you want to understand the mechanism, if you want to remember for a long time this mechanism means, first we have to understand the chemistry behind this. How exactly it will be going to be prevent the proton pump. That's very important because you might be know this mechanism, it is occurred in the gastric parietal cells. You might be know this mechanism, it is occurred especially in the gastric, in the stomach. Then what happened? The name itself indicate proton pumps. It means it is going to be pump the proton. How it will be means, for example, you can take the best enzyme for this one, H plus K plus ATPase. This is the enzyme. This enzyme, what it is going to be do means, it is going to pump the proton. Remember this. It is going to pump the proton. This proton, where it will be in the gastric parietal cells, it will be go and it will be bind with the chloride ions. Then what it is going to be produce after binding? Hydrochloric acid. That's why what we will call in the stomach, gastric parietal cells, the gastric secretion, it is going to be increases. Means what is the reason? This enzyme pumping the proton to meet with the chloride to produce the hydrochloric acid. This mechanism only we are going to be prevented by using what? Proton pump inhibitors. What are those proton pump inhibitors who will be have? Different drugs will be have under this class. What are those? Omeprazole, lansoprazole, pantoprazole, esomeprazole. All these drugs, they are going to be prevent this. What they are going to be prevent? They are going to be prevent the enzyme that is called as the H plus K plus ATPase enzyme. That's why it is not going to pump the proton and no acid secretion. That's why they will be called as the proton pump inhibitors. But the mechanism, inside mechanism is very, very important. How it will be? See, all these drugs, you take omeprazole, you take lansoprazole, pantoprazole, esomeprazole, all they are having the particular this group. What is the name of this group? Sulfonyl methyl group. This is called as the sulfonyl methyl. Why I am telling about this group only? Because this group only playing the vital role in case of mechanism of action. Remember, this group only playing the vital role in the mechanism of action. For example, you take the omeprazole. Omeprazole, it is the proton pump inhibitor. It is in the form of inert, means initially it is inactive. It is in the form of prodrug, you can say. Inactive omeprazole. When it will become active, means here it is going to be convert. Especially here you might be observing, no? Okay. Then this will be bind particularly here. And this, it will be move out this bond here. And slowly this will be coming towards this. It means what? and this particular sulfonyl group, it will be coming towards this side to this nitrogen. Then what it is going to be formed here? This is called as the sulfonamide group. It is going to be formed. This is very important. Which one is called as the sulfonamide? This sulfonamide. Okay, just remember that here this is the two steps reaction. No need to be that much deeper about this. Just remember that here it is going to be formed the 6-membered ring by fused with this nitrogen here exactly. Okay, imidazole nitrogen. Okay, then it will be forming the 6-membered. This is called as the sulfonamide group. What it is called? Sulfonamide. Now this sulfonamide group, it is going to be break. Here I shown. It is going to be break. When it is going to be break, when it will be react with the ATPase enzyme. Here another thing you have to be remember, all the ATPase enzymes, they are having the mercapto group because it is the part of the cysteine. They will be having the mercapto group. This mercapto group, what exactly it will be do means, this hydrogen, it will be goes here to this nitrogen, and whatever this sulfur is there, no, this sulfur, it is going to be form the new bond with this sulfur like this. Here hydrogen will goes, here sulfur, it will be form the bond with another sulfur of the which enzyme? ATPase. This type of bonding we are calling as the disulfide. What we are calling? Disulfide. Sulfonamide is active form. All these drugs you might be take omeprazole, lansoprazole, pantoprazole, whatever it may, esomeprazole and rabeprazole, all these drugs, they are having this sulfonyl methyl group. That is the reason they are going to be formed the sulfonamide like this. This sulfonamide, it will be react with the enzyme which is responsible for the pumping of the proton, that is H plus K plus ATPase. ATPase, what it will be having? Mercapto group it is having. That mercapto group, it is going to form the disulfide with the sulfonamide. Sulfonamide is the active form. Then it is going to be formed the disulfonide. Disulfonide means what here? It is going to be block this enzyme. Which enzyme? ATPase. When it will be block this enzyme, what happened? No production of the hydrochloric acid. No production of the hydrochloric acid. That's why they are all these proton pump inhibitors. You take rabeprazole, you take omeprazole, lansoprazole, pantoprazole, esomeprazole, all they are going to be useful in the various diseases which will be related to the secretion of the acid, especially in the GIT, in the stomach. That's why these drugs, remember its applications. These drugs helpful in the treatment of, I will write here, GERD. These are the uses of the proton pump inhibitors. Useful in the treatment of GERD. GERD means what? What is meant by GERD? Gastric esophagus reflex diseases or disorders. Gastroesophagus reflex disorders. Or another disease also it is useful, that is called as the Jollinger's disease. Jollinger's is nothing but the acid secretion will be heavily increases by the stomach. That is called as the Jollinger's. If you remember these two uses, then for all the drugs you are going to be write the same uses, because they are going to be prevent the proton pump. That's why they are called as the proton pump inhibitors. What is the inside mechanism means? See, now chemically if you come to know how the sulfonamide is formed, how the disulfide bond formed, how it is going to be block the ATPase enzyme, Once you come to know, it's very easy. You can remember for the long time this one, how it will be going to be function in our body. That is in the gastric parietal cells. Just we are reading, it is going to be prevent the proton pump, it is going to be prevent the proton pump, that is H plus KT plus, in one word. It is very difficult inside how exactly it is going to be happen. We cannot find out. Okay, I hope you might be understood the mechanism of this proton pump inhibitors. Okay, now we'll go for the different drugs which will become under in this class. All these drugs, they will be called as the proton pump inhibitors. Okay, we'll go one by one. We'll take the omeprazole. I will write the structure of omeprazole. This is belongs to the class of benzimidazole. Here it will be having the sulfur attached to the methyl group CH2, and this will be going to be attached with the pyridine. This pyridine, it will be having the methyl group opposite to this nitrogen. Here it will be having the methoxy group, that is called as the OCH3. Here another methyl group. At the fifth position of the benzimidazole also, it will be having the methoxy group. This is the structure of the omeprazole. Here it will be having the sulfone group. Okay, this is called as the omeprazole. How it is going to be synthesized, this omeprazole? I will write the synthesis now, because synthesis is very important in this case. For the synthesis, you divide this molecule into the two parts. Remember this, what we are going to do? We are dividing this molecule into the two parts. Okay, this is a very simple process what we are going to be do here. Okay, now see, I will break this molecule into the two parts. From here, then one part I will write here. I will take initially this pyridine. Pyridine, what it will be having? At the second position, it will be having the methanol. It is called as the CH2OH. Here it will be having the methyl at the third position. Fourth position, it is having the methoxy. Fifth position, it is having another methyl. It means what here? Which position? See here, 3,5 dimethyl 4-methoxy pyridine. Pyridine's which position? Second position substitution is there. That's why it is called as the 2-yle. What group it will be having? Methanol. This is the name for this one. 3,5-dimethyl 4-methoxy, because you give the number in 2, 3, 4, 5. 3,5-dimethyl 4-methoxy pyridine 2-yle methanol. Here it will be having the methanol. This is the one molecule. Okay. 2-methanol also you can write. Now in the next step, it is going to be react with the thionyl chloride. This SOCl2, it is called as the thionyl chloride. Always remember, it is what it is going to be do. It is going to be introduce the chloro group in place of hydroxy group. Which one? Thionyl chloride. Remember that. That's why what will you be get in the next step? You see, same molecule, pyridine, para position methoxy, methyl. Here also methyl. Here Cl, CH2, Cl. Okay, is the intermediate, chlorinated intermediate. Now in the next step, what exactly it is going to be happen means, it is going to be react with the benzimidazole. Which benzimidazole? Remember here, that benzimidazole, fifth position, which is having the methoxy group fused with imidazole. That's why it is called as the benzimidazole. Then this position, what it will be having? Mercapto, that is SH. Now see what happened in this reaction. This hydrogen, this chlorine, they goes out in which form? Hydrochloric acid. Then what it is going to be formed? Just see, same structure it is going to be formed here. There is not much space, I will write small. Oh, sorry. This is going to be formed. So with the sulfur bridge. This bridge, for this bridge only, all these things we are doing for formation of this sulfur. Now in the next step, it is very, very easy. It undergoes the process of oxidation. What it is called? Oxidation. For oxidation, it is required the hydrogen peroxide H2O2. Now see, this sulfur, it is going to be oxidized to produce the omeprazole. I hope you might be understood. Initially what happened? Alcohol, it is converted to the chlorinated form with the help of thionyl chloride. Then next what happens? This hydrogen of this benzimidazole react with chlorine to go out hydrochloric acid to produce what? That sulfur bridge compound. Then it will be undergoes the oxidation on the sulfur to produce the omeprazole. This is the synthesis of omeprazole. Okay, uses are very simple. Mechanism for the omeprazole already I showed. It is the prodrug. It is in the form of inactive. When it will become active, when it will be react with the specially what? When it will be going to form the sulfonamide group, then it will become active. What I shown in the mechanism. Okay. Then after that, it will be react with the ATPase enzyme. Then it will be prevent the action of the H plus K plus ATPase to prevent the pumping of the proton, to act as the proton pump inhibitor. When it comes to its uses, it is used in the GERD, gastroesophagus reflux disorders, and along with that, it is useful in the Jollinger's disease also. GERDS and Jollinger's. In both the cases, it is going to be very, very useful. Okay. Like this, the other drugs also, like lansoprazole. Lansoprazole also similar to this, but omeprazole, here it will be having exactly, here it will be having the methyl group, here methoxy, here another methyl group. But in case of lansoprazole especially, here methyl group it will be have, but this methyl group is not there in case of lansoprazole. Instead of this, that will be attached to the one more carbon. Here 3 fluoro groups are there. This is called as the lansoprazole. See, minor difference. This is called as the lansoprazole. Here it won't have the methyl group, but here it will be having the trifluoroethyl group attached to oxygen. That is the difference, and it won't have this methoxy group, especially lansoprazole. But omeprazole, methoxy group is there, here methoxy is there, here methyl is there. Like that esmoperazole also. Esmoperazole, here it will be having the methoxy group. That is not there in case of lansoprazole also, omeprazole also. Here it will be having the another methyl group. See the difference. Okay, another methyl group. Then it will be get the positive charge. Then methyl group is common, but instead of trifluoroethyl, it will be having the methoxy. Esomeprazole. Like this minor differences are there. Like that you can take the rabeprazole. You can take the next pantoprazole. Pantoprazole, it won't having here any methoxy group. They are having the difluoromethoxy group here at the 5th position of the benzimidazole. Then here it will be having the methoxy groups only. This position also, this position also. Here it will be having the methyl, here methoxy, here methoxy. It won't have this methyl group. Now this is called as the pantoprazole. Like this next drug is the rabeprazole. Rabeprazole, it won't having substitution at the 5th position, no substitution. Here it will be have the methyl group. Here you can see here it will be having the ether linkage to the propyl group. Remember this ether linkage to the propyl group, and at the end it will be having the another methoxy. It won't have any methyl group here. All these drugs you can take omeprazole, rameprazole, esomeprazole, lansoprazole, pantoprazole. All they are useful in the GRD Jollingers. Means one thing you remember, they are going to prevent the secretion of the acid in the GIT, that is the gastric parietal cells, by preventing the which enzyme? H plus K plus ATPase. Okay, by preventing, because it is going to be form the disulfide bond with this, then it prevent the pumping the proton to be act as the proton pump inhibitor. Okay, I hope you might be understood this topic. Okay, these are all the drugs. Mechanism is same because all they will be contain the sulfonyl methyl group, all the compounds. That's why mechanism it will be remain same. All they are going to be prevent the ATPase enzyme. Okay, thank you very much. We'll be meet in the next class. Until then, bye bye.